Hello everyone, thank you for checking out A1 Math, and today we are converting our compound interest formulas into function notation, and we're going to use that with population increase and decrease. Okay, so you want to show the increase and decrease with population, and that's going to be an exponential function where your variable is going to be your actual exponent. Okay, so let's take a look at a couple of examples. All right, so here's our regular compound interest formula here with our principal, rate, and time. Now, we're not solving and finding out the amount. We're just changing, so when we put in our independent value, which is our time, instead of putting it into the compound interest formula, we're putting it into a function notation formula, okay? Now, even though it's function notation, I'm gonna leave the A for the amount, which is the population here. All right, so let's take a look. So our regular formula here on this first one here, Blueville has a population of 7,000. Its population is increasing at a rate of 1.4%. Okay, so we have the rate, we have the principal. It's the time that's going to stay a variable, and we're going to change the way it looks by using actually just addition and subtraction. So here you go. We start off with A is equal to our principal, 7,000. All right, it's times 1 plus our rate, 1.4% converted into a decimal, which is 0.014, raised to the t. Now, that's our compound interest formula. But we could simply just do the addition here, and that's going to get us 7,000, put A in front here, 7,000 times 1.014 raised to the t. The same thing, just it looks different. All right, so all we have to do in order to solve, we'll plug in whatever year we have, and that'll tell us the amount. Now, the reason we put this in and made sure it was positive is because it's increasing. Now, if it was decreasing, it would be different. So let me show you one where it's decreasing. So skip down here to number 11. You have A is equal to our principal, 8,000, times 1. Now, since it's decreasing, instead of putting positive by the rate, it's not going up at 1.75%, it's going down at 1.75%. So we want to put a minus sign here and convert this into a decimal. And then raise it to the t. Now, but previously adding it was real easy. You just put the 1 there. But here you got to actually do the subtraction. So you'll get A is equal to 8,000. All right, and when we do 1 minus 0.0175, we end up times 9.825t. Okay, so it's now positive, but as we plug in these different numbers, it's going to decrease. All right. So let's take a look over here at Waynesburg. Okay, it has a population of 16,000, and it's steady going up. We're going to take a look at how it is over some years and what they expect it to be. So you can make this projection onto what Waynesville would look based on the rate of its growth previously. Now, first, I'm going to show you with the compound interest formula how they converted and got this. Same thing we've been doing. We'll take the A is equal to the principal, 16,000, times 1 plus the rate, which in this case is 0.015. Okay, and raised to the t. When we convert this, or just add the 1 plus 0.015, you get the formula that's given here. It's just called function notation. And they put the population as a function of time right here. All right, now, you can use either one, but I'm gonna go ahead and use the function notation and plug those in to find our values here. Okay, so in my first example, I'll take the 16,000. Okay, and multiply it times 1.015 raised to the t, but in this case it's going to be 1. And you type that in the calculator. And let's go get you 16,000 times 1.015 and raise that to the 1. That's going to get you 16,240. Now, if you want to do 3 years, we'll simply just hit second and enter again, tab over, and change this to 3, and get our answer there. All right, and that gets us, and we'll round to the nearest whole number here. So in 3 years, same formula, but instead of having 1, you're going to have 3. As your exponent, and your answer is going to be 16,730. And let's just round it up to a whole person. Okay, so that's about how much you should have in 3 years here. And you can take a look to see what it's going to be in 5, 10, 20, and 50 years, and find that exponential growth in that population. So again, this has been converting the compound interest formula into function notation and using it to look at population increase and decrease. And again, I want to thank you for checking out A1 Math. Have a nice day.